right? The ECI coordinate system, we have been discussing this for some time now. How is it defined? The ECI coordinate system, we have the x-axis or the I direction. This is the Earth's axis of rotation, right? Is it? This is not Earth's axis of rotation. This is vernal equinox. Okay? We represent this by this symbol. Right? The z-axis is axis of rotation. K direction. In the right-handed sense, right? And y is simply, it completes the z cross x. Okay? In this context, we also need to understand, and we discussed this, PQW. What is this PQW frame, reference frame or coordinate system also called? Perifocal coordinate system. Okay? And here, P direction is the perigee direction, right? W is this is the H direction, okay? Vector H.
What does that say after I direction?
Vernal equinox. Okay? This is the symbol, Aries symbol. Okay? H is this is the angular momentum direction. And Q is simply W crossed with P. Okay? So here it is Z crossed with X, or J is K crossed with I. Now, alright, we have been looking at the other figure, but you should be able to understand these elements or these coordinate system looking at any frame. Okay. Now, look at this, guys, and tell me, do you identify these two frames, coordinate systems? A coordinate system, here, stop writing and stop cell phones. What you need is, for a coordinate system, of course, you can do it with two axes, two known directions, right? And the third completing the triad. You understand? You can also do it with a plane, alright? And it's perpendicular to the plane. What plane is ECI coordinate system in? Right. So hang on. The ECI coordinate system, what is it also called? Geocentric equatorial frame. Okay. Now what plane is this on? The equatorial plane.
The
XY plane. Don't say x-axis. X-axis is not a plane. X-axis is what? Huh? It's an axis, it's a direction, it's an axis. How many axes do you need to form a plane? 2. Okay? So you see this and this form the equatorial plane. You understand? And the perpendicular to the equatorial plane is the axis of rotation here. Got it? That is one coordinate system. Clear? Now look at this. What plane is this frame in? Coordinate system in?
Looks like the
Orbital plane. You get it? To define a coordinate system, you can do it if you have a plane. How many axes would you get if you define the plane?
Oh, 3. Well,
Define a plane.
2 axes. Yeah, 2 axes. 4 planes. It sounds like a trick question.
How many axes will you get if you define a plane?
2 axes.
1 axis. How many axes can there be in a plane? Which is for sure in a plane? Which axis is for sure in a plane? The axis perpendicular to the plane is a surety. This is for sure. But how many axes, XY axis are there in a plane? Infinite. It's a circle, right? How many other planes can be there, right? But only one can be perpendicular. You get it? So if you define a plane, you have to define at least one of the axes in that plane. Does that make sense? If you define a plane, you have defined the perpendicular to that plane. Only that is for sure. Make sense?
Yeah.
The axes in the plane are not sure. There are infinite axes in the plane. Axis perpendicular to plane is the only surety. Does that make sense? So if you define a plane, what axis is defined in this plane? This x-axis. This is, if you define the plane, the k is automatically defined. Right? You don't have to define the plane, the axis separately. Got it? It's understood. What is the axis in the plane that needs a definition? You got it? So if you do this k cross x, you get 1. Got it? So you define a plane and you define an axis in the plane. At least one direction in that plane. You get it? Yes.
So is that just like a random axis?
Huh?
Is that just a random axis?
No, this is not random axis. This is, we said, right? This is Yeah, this can be anywhere, right? But we define this. So in that plane, now if you define this as a plane, there's only one perpendicular to this plane, right? But if you want to establish a coordinate system, you have to establish one of the known directions. You can say from the center to the corner, if I define it as x-axis, you understand? Then the perpendicular to that will be the y-axis. You get it? But I have to define that corner or this corner or this corner or board, some one direction. But there are infinite axes in this plane. But are there infinite perpendiculars to this plane? Only one. Right? Got it? Now similarly, how do you define this? This h is automatically defined. Right? H is the direction of the orbiting body. Got it? We define this p direction. This p direction is only one. Right? It is in the plane. P direction. Does that make sense?
Say
The second plane is this orbital plane, okay? It's going this way. This P is a very specific point, right? You get it?
Yeah.
That is the point of closest approach. So the line joining, if you define this as the P direction, okay? That P, you see that? This H is W, essentially. You get it? Okay? This Q will be in the plane again, perpendicular to both W and P. You understand? Now, you see this R, it's a vector, right? R is the position vector. In what frame can you express it?
It's in that moving frame because you got a satellite inside the ring.
No. In what frame can you express it? ECI or PQW?
PQW. PQW. ECI.
It can be expressed in either frames, right? The components will change. You can define it. So that's what I'm trying to get to. Okay. If you have, I'm just going to use a two-dimensional. We'll scope this discussion to two dimensions, and I'll tell you how to do this. Okay. So you have this is, let's say, x1, y1, okay, and this is x2, y2, right, and this is some vector r. In what frame is this r can be defined? There are two frames here, xy and x1, y1, okay, or x1, y1 and x2, y2. It can define in both. Okay, if this is the, I'm going to just put this as here. Okay? Now, let's say this is theta 1 and this is theta 2, and this vector is r. So r can be written as r cosine theta 1 x1. You agree? Right? Plus r sine theta 1 y1. But r can also be written as r cosine theta 2 x2 plus r sine theta 2 y2.
Why is it cosine and sine? Like, why is it?
Why is that like that?
Why do we choose cosine for data?
You tell me, why is it like that?
It's true.
Yeah, I'm just. If you do data one, Jason tells me. A lot of people tilted.
Okay, so this is, this component is x, right?
Yeah.
This is r sine theta, r cosine theta, right?
Yeah.
So that is x component.
Okay.
You get it?
Yeah.
This is the y component. This would be the y component. That will be r sine theta. Okay?
I don't know.
So if you look at, if you have something like this is r, okay? This would be the y component. This would be the x component, right? This would be r cosine theta if this is theta. This would be r sine theta. If this is theta, this would be r. If this is theta, this would be r cosine theta. This would be r sine theta. Okay?
I was just like, in terms of it becoming a vector, I was just thinking you wouldn't add those numbers together, would you?
You would have, you cannot add these two.
Yeah, that's what I was saying.
It's a vector, that's the reason it's a vector. You cannot add the components. Okay? Vector by definition has three components. Here this vector is expressed in as two components because we are talking about only two directions, 2D. But by definition vector has three components which cannot be added. They are separate components. Okay.
Can you explain how we can get R from the second equation? I see it for the first time, so yeah.
It's again the same thing. You just draw perpendicular to this, okay, to x2,
Oh, okay.
the same vector, right? So this would be r cosine theta 2, and this would be r sine theta. Okay? What I'm trying to get you to understand here is this r vector, which is a position vector, can be coordinatized in either the ECI frame or in the PQW frame. If it is coordinatized in the, Michael, keep your cell phone away. Give your cell phone to somebody else. Give it to Christian. If you look at R, okay, I'm going to make this statement. Try to justify the statement for me, okay? The R vector does not have a W component if it is coordinatized in PQW frame. Vector R, if it is coordinatized in PQW frame, it does not have a W component.
That is R does not have magnitude.
Just because it's in that frame.
If R can be coordinatized in, if R is coordinatized in ECI frame, okay, it will have X, Y, Z components.
Right.
If it is coordinatized in this frame, it will have P and Q components, but not the W component.
Because it's angular.
I'm talking about R.
Yeah.
Because it's in the frame.
It's in the plane, not frame.
No plane, that's what I mean.
Yeah.
Okay.
So if think about this. If a vector is lying flat on this surface, will it have any component perpendicular to this surface?
No.
So that is what is happening with R. R is in the PQ plane. You see that?
Yeah.
It does not have any W component. Got it? But R has all three X, Y, Z components. Does that make sense? So here we can write R, and that's what we have been doing. R ECI can be written as see if this makes sense, okay? If I take a vector in R, a vector R, coordinatized in PQW frame, and guys, pay attention here. None of you are paying attention. Pay attention here. Try not to get distracted. This is very, very crucial because you're going to get this on your exam. You take a vector R. The vector is coordinatized in PQW frame. You multiply by this transformation matrix. You get that vector in ECI frame. You know what a transformation matrix is? So here, I'll tell you what the transformation matrix is, okay?
Is that R like is it double underline?
Double underline, that's a matrix. So that's the reason it's a double underline, okay? So here you recognize there are two frames here, right? Everybody agrees with that? There are two frames. X1, Y1, X2, Y2, right? How do you go from X1, Y1 to X2, Y2? Can I write X2 as so here this is X1, Y1. Where would Z1 be? It would come out of the board. Got it? So it's fairly simple, right? This is X2, Y2. Okay? Again, where would Z2 be?
Sure.
If this was Y1, this was X2 or X1. It will go inside.
Oh.
It is right hand rule, okay? So X to Y would be Z. Okay, now it is this way, right? So it is coming out. If I change these two, it would go in. Alright?
Can you say that one more time?
So it's always X, Y, Z. Alright? So you see X, Y, Z coming out. Right? If I flip these, it would be X, Y, and going. You get it?
Yes.
So let's say this angle is theta. This angle will also be theta, right?
Yeah.
Right? We are talking about orthonormal systems, or here x1 is perpendicular to y1, x2 is perpendicular to y2. So your x2 would be written as vector x2 would be written as x2 cosine theta in the x1 direction. You with me? Plus x2 sine theta in the y1 direction. You get it? Similarly, y2 would be minus y2 sine theta in the x1 direction plus y2 cosine theta in the y direction. Does this make sense?
Can you explain why it's negative real quick?
Yes. So the components are these, right? Everybody agrees? This is the y component of x2, right? This is the x component of x2.
Right.
So you see, this is in positive y direction, right?
Yeah.
This would be sine theta, right? This is in positive x direction, but this is cosine theta. x2 cosine theta, x direction. x2 sine theta, y direction. Right?
Right.
Now we look at this. This is the x component, right? It's in the negative direction. x1 is that way. This is going that way. Right? This is sine theta, right?
Yeah.
This would be the, again, but this is positive. This remains positive, right? Because it's going this way. This is the sine theta. So you see, minus y2 sine theta in x1 direction plus x2 cosine theta in y1 direction.
Should the left one be cosine theta?
If you have
On
sine
y2?
theta,
On y2, the left one should be cosine theta?
because you have,
This one?
Yes.
yeah. Because you have sine theta twice.
Yeah, right. This is cosine theta. My bad. Okay, this is cosine theta, yes. So this is the same as this component, guys. Okay? Does that make sense? This is same as this. You with me? Alright? If I now, if this were, if all these were unit vectors, which is the case in most,
Sorry, can you back up to the word?
yes, go ahead.
If we would have drew a triangle the other way and got negative cosine, would that change your answer? Like, you know what I'm saying? Like, you see how you draw your triangle where your x is on top, who would where x is on the bottom?
No, it's the points. If it is this, it will still be the same.
Okay, that's all I'm
Okay, it's the same. Yeah. So here, if these were all unit vectors, what would this value be? 1, 1, 1, 1, right? So here you can write this as x2 equal to
X
cosine theta sine theta minus minus sine theta cosine theta
This is your transformation matrix?
This is the transformation matrix.
Okay.
So,
I wrote this as like this. x2, so x2 is what? Cosine theta x1, cosine theta x1 plus sine theta y1, sine theta y1. You got it? It's just written, your system of equations is written as matrix form.
Is
Everybody, huh?
X2 and Y2 a vector?
Say that again?
Is X2 and Y2 a vector?
Yes, all these are vectors. So this is not a vector, okay? But these are vectors. Alright? So here if you see, I just wrote the system of equations as a matrix form. You get it? This is that transformation matrix. This transformation matrix will transform a vector coordinatized in xy plane or xy frame to x2, y2 frame.
so that's
This is, so if you apply this to 3 dimensions, okay, you cannot, we don't exist in 2 dimensions, we exist in 3 dimensions. For all practical purposes, we are finding it difficult to even exist in 3 dimensions. So let's not go to 4 dimensions. Alright. So we exist in 3 dimensions, and so this is the transformation matrix which will transform from one coordinate system to another. So here it is PQW coordinate system to ECI coordinate system.
So, question. Will we only be able to do that if it's a unit vector? They have to be unit vectors, but that's how you.
No, this doesn't have to be a unit vector. We do it unit vector because when you're in rotation, so there are translational degrees of freedom and there is rotational degrees of freedom, right? So if you see here, we are mostly concerned about rotational. You get it? So we consider unit vectors. The reference frames are unit vectors. If you were talking about distances, okay? So R is a distance, right? Or R is a position vector. So what we do is we define the bases as unit vectors. What is a unit vector? What is the magnitude of unit vector? 1. So you can say R is so many units in the x direction. The base unit of x is, if it's a unit vector, is 1. So you can say R is so many x's means so many units. Okay, it gives a dimensions to that. You got it?
Yes.
So here it is cosine theta units of x1. It is sine theta units of y1. How many units of x1, y1? If you make them a unit vector, you can, you see?
Yeah. Okay.
Yes.
So what does R look like expressed in ECI
This will look like a 3 by 3 matrix.
That's for
This alone. Okay, so your R will still be here. This is 3 by 3. Okay, this is 3 by 1. This will also be 3 by 1. So 3 by 3, 3 by 1. If you multiply the inner elements cancel off, you get a 3 by 1, which is 3 by 1. Got it? Now, if you look at what we have been discussing with orbit determination, I keep telling you that R is given in, R and V are given in ECI, right? So this is what is given to you.
You probably have to find PQWR.
Right.
So you probably have to do that.
You may have to do that in the exam. And I have given you, in your assignment, you for sure have to do that.
Which question is it?
Just check. I don't remember the question number, but I've intentionally assigned you one problem for converting this.
Will you ever like ask it in like a reverse kind of way, like when you ask it to convert?
For the exam purpose, for this exam, I'll try to keep it as simple as possible. Okay? What I'm going to focus on is, what we'll focus on is right ascension declination. Okay? Right ascension declination to geocentric orbital elements. What are the orbital elements? Given a figure, can you identify the orbital elements? Okay? And given these two, can you find? No. What did we do?
The size, the shape.
We did this, right?
Yeah, is there,
This does all this. It doesn't involve any of this. You get it? If I give you these and ask you to find this, okay? If I give you this, the immediate answer you're going to get is this. Okay? Now, what you need to do is, from these, what is this? And just, if I give you this, okay, I won't ask you to calculate this. That will not be part of this exam. Okay? If I ask you to do this, you have to just write whatever you get. So pay attention here. It can be either ways. Everybody agrees? Understands that? Given R and V, you can find the elements. Given elements, you can find R and V. Understood? In the exam, in the assignment, I'm going to give you R and V in ECI. So it will be a direct calculation of these elements, one or more of these elements. Okay? In the assignment, what I've given you is, you're given these elements, you have to figure out R and V in ECI. Okay? You're with me? The problem, if you're given these, you'll very easily get this. You understand? But you have to convert this to this.
Right.
So if you just write in the exam that I get this, I'll multiply and I get this. That's sufficient for me. Does that make sense?
We would have to do that by using
Huh?
we
No, you don't have to do anything. If you just write this formula and tell me this is how I get this, that's sufficient.
how would you actually?
You don't, huh?
How would you actually work?
I would ask you to, again, that's the reason I'm saying, pay attention. You will be given these 6 elements. You'll be asked to calculate R and V. Okay? It's a direct calculation. But you're going to get R and V in this. You're going to get this R and V. But I'm asking you in ECI. So you have to just say, multiply this by this, I get this. You got it? I'll just do R for sake of it, okay? What is R? What is R, guys? A square over mu over 1 plus E cosine theta. Right? If I give you all of this, can you calculate this R?
Yeah.
So this R, think about this. You have this R, right? Okay? And this is your theta. Alright? This is what direction? P. You with me? This is Q. Where is W? Coming out. Okay, this is the orbiting body. This is how the orbiting body is going. This is P, this is Q. This R is what? This distance.
Right.
You understand? Now, what is the P component? P component is cosine theta.
Right.
You get it? What is the Q component? Sine theta. What is the W component?
P cross Q.
There is no W component.
Right.
You get it? This into this. So here, this R is simply R cosine theta. Okay? P direction. You get it? Plus R sine theta Q direction plus 0 W direction. But this is in PQW. Right? You get it?
Yes.
So you see, if I give you these, can you calculate this, this, and this? You can, right? R is here, everything is given here. Mu will be given to you. E is there, theta is there. So you know, you get R PQW. You get it? You get this. What I'm asking you is this. Right? You just have to say, multiply this R by the rotation matrix, you get RECR. Does that make sense?
Yeah.
You just have to say that. You just have to write it there. I don't want you to calculate this or anything like that. That's not for this example.
Rotational matrices in that one.
This one. You just have to exactly copy this and write that. This is an example what rotation matrix is. You don't have to do any calculations. All I'm asking you to do is, given these, arrive at this, and then just say R ECI is equal to R PQW to ECI R PQW. This is the only line I need you to say. Does that make sense? What I'm trying to get to you is, this vector can be coordinatized in the PQW frame, or it can be coordinatized in ECI frame, or it can be coordinatized in lat long frame, or it can be coordinatized in right ascension declination frame. The vector is one. It has infinite coordinatizations. That's what I'm trying to get to. You get it? This does not have a coordinatization. R, this is just a distance. This is what makes it coordinatized in the PQW. You get it?
Yeah.